Hello friend, welcome. Today we will talk about power factor. We want to know what is the power factor mean, what is the best power factor, why the low power factor is impact to the power system, and how we improve the low power factor. Okay, power factor is the cosine of angle between voltage and current in an AC circuit. So the angle between voltage and current that we take cosine of that angle is equal power factor. And if the circuit is inductive, the current lag behind a voltage and a power factor is referred to the lagging. But in capacitive circuit, we know that the current lead voltage and a power factor is said to be leading. We want to know also the range of power factor. What is the value of power factor? The power factor takes the range between 0 and 1. Between 0 and 1. So also we want to know the type of power. As you know, there are three main types of power. Active power, that measured in watt or kilowatt, and reactive power in var or kilowatt. So number 3, we have also apparent power in volt ampere or kilovolt ampere. So in this triangle, we know that we have represent this. We have this side, a long side is represented to the apparent power, and this side is to the real power, that we mean active power, and this side is a reactive power that we know. So if we come here from a figure, from that figure we know that voltage times current times cosine of theta is represented to the active power in watt or kilowatt, and voltage times I, which represents the current, times sine theta is represented to the reactive power in var or kilowatt. So also voltage times current, also it is represented to the apparent power in volt ampere or kilovolt ampere. So we know that power factor is equal cosine of angle between voltage and current. And this is voltage is equal cosine of angle between voltage and current. So, and also it is equal active power divided by the apparent power, which is equal kilowatt divided by kilovolt ampere. And it is also equal resistance divided by the impedance. Resistance divided by the impedance. So we know what is the disadvantage of low power factor. What is the low power factor causes? Low power factor causes more problem to the system or to the power system. As you know, the one of this problem is a large kilovolt ampere rating of equipment. So electrical machinery and alternator, such as alternator, transformer, and switch gear, is always rated in kilovolt ampere. So kilovolt ampere is inversely proportional to the power factor, because kilovolt ampere or rated power or apparent power is equal active power divided by the power factor. So if the power factor increase from this our rule, Here we find if the power factor increase, the kilovolt ampere decreasing. If the power factor decreasing, so the kilovolt ampere, or which is apparent power, is increasing. Okay, number 2, we have it need greater conductor size. Okay, to transmit or distribute amount of power as a constant voltage, the conductor will have to carry more current as a low power factor. So in the low power factor, you need greater conductor size to distribute your power. Okay, number 3, large copper losses. So the losses in the low power factor is more and more. As you see, the large current as a low power factor causes more losses in all elements of the supply system. Okay, number 4, we have also the large voltage drop. As in the low power factor, you know that the large voltage drop, so the voltage drop will be very high. So the large current as a low lagging power factor causes greater voltage drop in the alternator, transformer, transmission line, and distributor. Number 5, it reduces handling capacity of system. So you know lagging power factor reduce the handling capacity of all elements of the system. What is causes of low power factor? What is that? What is the in the system, which thing causes low power factor? The following are causes of low power factor. One of them is the induction load, such as single phase or three-phase induction motor, which have low lagging power factor. Also number 2, arc lamp, electrical discharging lamp, and industrial heating furnace operated as a low lagging power factor. So number 3, also the load on the power system is varying. Yes, the load on the power system is varying, is changing, being high during the morning and evening and low at the other times during low load period. Supply voltage is increased, which increase magnetization current. This result is decreased power factor. Okay, power factor improving. How we improve the low power factor? As you know, the low power factor is mainly due to the fact that most of power load is inductive. So in order to improve the power factor, it should connect the capacitive in parallel with the load as shown in a figure A. As you see here, we connect the capacitive in parallel with the inductive load, and this result is improve the power factor. As you see here in this figure or figure B, you know that this is a resistive circuit. In the resistive circuit, voltage or current as rising and falling in the same time. As you know, this is in this circuit or in this resistive circuit, power factor is equal 1, and this is the best power factor. So, and the resistive load, and what is the resistive load? Anything produce heating like water heating and clothes. This is the resistive load. So in number 2 or this figure, you see this is the inductive load, inductive circuit. In the inductive circuit, the voltage or current is a lagging voltage. So voltage is rising and falling after that voltage current is rising and falling. So in this circuit, the power factor is low. So to improve this problem, we connect the load in parallel with the capacitive which is produce this circuit, capacitive circuit. In the capacitive circuit, as you see, the current is rising and falling before voltage is rising and falling, and this is good power factor. Thank you very much. Don't forget to subscribe our channel and make the bell to receive as a notification. Thank you very much.